Hello, this is Scholar Strive doing some math. Today we're going to learn about the hinge theorem. Inequalities in two triangles and indirect proof. So the hinge theorem basically says if two sides of one triangle are congruent to two sides of another triangle, and the included first triangle is larger than the if the first triangle is larger than the included angle of the second triangle, so this one's 80 degrees, this one's 60 degrees, these two sides are the same, then the third triangle of the first, or the third side of the first triangle will be longer than the third side of the second triangle. So let's call this A, B, C, D, E, F. So AC is bigger than DF. And it's called the hinge theorem because if you open a door, so we have the door here, and if you swing it open, or let's say this is the door, and here's the doorway, and then we open the door like this. The door is still the same size and same as the doorway, right? So these two are the same, and then the doors are exactly the same. But if you open it wider, and make the triangles, then the third side will be bigger. And then converse of the hinge theorem, so you can work backwards. So if the third side of one triangle is congruent to, if the third side of one triangle is bigger than the third side of another triangle, and these two sides are congruent, then, sorry, let me try that again. So if two sides of a triangle are congruent, and this third side is bigger on the first triangle than the second triangle, that means the angle opposite of the third side of the first triangle is bigger than the opposite side of the third side of the second triangle. Okay, and we'll talk about indirect proofs in a second. So we have this side the same, we have this side the same. Okay, so we're comparing angle 1 and angle 2. So opposite of angle 1 is 34. Opposite of angle 2 is 33. That means, by the hinge theorem, angle 1 is greater than angle 2. Bigger the side, bigger the angle. Example 2. Car A leaves a mall and drives due north 5 miles, then turns west and drives 3 miles. Then car B leaves the same mall and drives south 5 miles, turn 80 degrees towards the east. And drives 3 miles. Which car is farther than the mall? Okay, so this is 100 degrees. Oops, what is this? No, thank you. So this is 100 degrees. Why? Because 80 plus this angle is a straight line. The straight line is 180 degrees. So this is 100. And we know if that's 90, then this is 90 degrees as well. Okay, so if we know those two angles, and we know that these two sides here are the same, and these two sides are the same, therefore this third side of car B is farther away from the mall than car A. Because this is 100 degrees, opposite of the 100 degrees is the larger side. 90 degrees should be smaller than 100. How to write an indirect proof. So you might like these. So identify the statement you want to prove. Assume temporarily that the statement is false by assuming that the opposite is true, and then reason logically until you reach a contradiction. Point out that the desired conclusion must be true because the contradiction proves the temporary assumption false. So let's do an example to explain this. So write an indirect proof to show that x cannot be equal to 9, given that x plus y is not equal to 14 and y equals 5. Okay. So what you're trying to prove is x is not equal to 9. So we're going to assume the opposite. Assume temporarily that x does equal 9. That means x plus y is not equal to 14, or 9 plus 5 is not equal to 14. However, this is false because 9 plus 5 does equal 14. Therefore, x cannot equal 9. Okay? So what you do is see what you're trying to prove. Assume the opposite. So x is not equal to 9. The opposite is x equals 9. Put it in your formula or put it into your logical statement there. And you'll run into a contradiction. And then because of that contradiction, you can say that the thing is true. That you prove what you're trying to prove is true. Alright, so if the measure of angle ABD, so let me use colors here, ABD is bigger than CDB, so blue is bigger than red, which is longer. Oh, sorry, I messed up. CDB is down here. I was like, that doesn't make sense. ABD is down there. So if blue is bigger than red, which is longer, AB or CB, it would be blue here, opposite of the blue. So AB. That's by hinge theorem. There's two sides that are congruent here. The blue angle is bigger than the red, so the blue side will be bigger than the red side. Alright. AB is, oh, we got a proof going on here. So proof by indirect proof. Indirect proof are in paragraphs. You don't write statement and reason. You don't have to write out the given or anything like that. You just start off by what we wrote here in the example 3. So assume BC is congruent to DC. Okay. So assume BC is congruent to DC. So first, let's mark our picture with what's given. So AB is congruent to AD, and they say angle BAC. So this angle is not the same as this angle. Prove that BC is not equal to DC. So we're going to assume that BC is congruent to DC. So by hinge theorem, angle BAC should be one second. Assume this is, well, actually no, not by hinge theorem, but so assume that BC is congruent to DC. Yeah, by hinge theorem. So by hinge theorem, angle BAC should be equal to angle DAC because AB is congruent to AD and AC is congruent to AC. Okay, because we have the two sides being congruent. So if BC is congruent to DC, that means these angles must be the same. However, this contradicts the fact that angle BAC is not congruent to angle DAC. Therefore, in conclusion, BC cannot be equal to DC. So you assume that the opposite is true, and then using logic and reasoning, you contradict one of your given statements. So by the hinge theorem shows that one angle should be bigger than the other. But if the sides are the same, that means the angles should be the same as well. In this case, the angles are not the same because of the given statement. Therefore, these sides cannot be the same as well. And that is all for today. Have a good one.